So this is our presentation. Is from Mapua University, Building Stronger Cities Through Nanotechnology. This is our group in STS with Professor Lazo. So we were assigned to give a presentation of an innovation that is related to our specific course. So this specific application of nanotechnology is related to building, to construction, specifically enhancing soil stability. So in this overview, we will have the introduction, and later we will discuss traditional soil stabilization. Then we will have the overview of nanotechnology in soil stabilization. And then we will talk about the limitations of traditional soil stabilization and the advantages of nanotech soil stabilization and the types and its feasibility. So the background is that soil stabilization has long been a cornerstone in civil engineering, aiming to improve the strength and durability of soil in various construction applications. So the traditional methods include mechanical, chemical, and geosynthetic, which help reinforce soil, but often come with limitations like high cost, environmental impacts, and insufficient performance under extreme conditions. With advancements in technology, nanotechnology presents a promising alternative, allowing engineers to modify soil properties at a microscopic level, offering higher precision and efficiency. So yeah, because this is particularly important, soil stabilization specifically. It's important in construction, especially in times where you would want to build something or build an infrastructure that is, for example, on land that is not on flat ground. If it was on a mountain, if it was on an area where basically you can see certain risk factors for landslides. For example, if you see trees that are not straight, if you see them they're slanted, that's like the symptom that would indicate that there is a chance for landslide. So oftentimes the client would want to go to a geotechnical engineer or a civil engineer to consult before they purchase a piece of land, whether it is viable to put soil. And this is the field of soil stabilization in civil engineering and in geotechnical engineering. So we're going to explore the efficacy of nanotechnology and compare its advantages with traditional methods and assess its feasibility. And we're also going to provide insights to the types of nanoparticles used. So traditional soil stabilization is a science of enhancing the physical properties of soil to improve its strength, durability, and lead-bearing capacity. So, like I said, when someone goes to the engineer to ask if the piece of land is viable to build on, most of the time they will conduct studies and they will do some kind of they will insert holes into the land and conduct studies to check the properties of the soil that's in there, what kind of rocks can they see, and then they will determine if it's either just don't build there, or maybe they can put certain different types of rocks and to modify the physical properties of the soil through various techniques to make it possible that the client would want to put or build an infrastructure in that area. So yun, traditional soil stabilization methods are either done mechanically, chemically, and geosynthetically. So the overview of nanotechnology in soil stabilization. Nanotechnology provides engineers to access a new level of precision and control. Nanotechnology has created new opportunities for stabilizing soil by providing ways to increase durability, decrease permeability, and strengthen soil. So when we say decrease permeability, that's permeability to water, because if we increase the moisture content of the soil, it will make it less stable. So the limitations of traditional soil stabilization is, despite their success, traditional stabilization techniques have some drawbacks. So number one is soil type dependency. Soil types react differently to stabilization treatments. One drawback of traditional soil stabilization is its reliance on soil type. So it's not ideal method for everything. And then the environmental impact, chemical stabilizers in traditional soil stabilizing techniques can have major negative influences on the environment. And this is one big problem that is really encountered, is durability. So a number of things include exposure to water, so that's the moisture content that we're talking about. Chemical deterioration and biological activity can compromise the durability of the stabilized soil. So we also have to take into account the fact that there are many small organisms that live in the soil, and that can also impact the integrity of the soil. So the advantages is the improved soil. For example, one is improved soil strength and compaction. Through the use of nanoparticles like nanosilica, nanotechnology can improve soil strength by filling the voids between soil particles, enhancing the soil's compaction and load-bearing capacity. So, mas lalong nagiging pino and mas lalong nagiging siksik yung soil. And because of that, of course, if you want to put up a strong structure in a land, for example, that is mountainous, you want to build a resort, you want to make it as durable and as, what do you call this? Sorry. Safe for everyone who's going to use it. So, the more stronger the foundation is, the better. So one of the advantages also is enhanced durability and reduced erosion. So that's one of the concerns, is erosion, because soil moves. Soil can be seen as something that is living because it moves because of the natural forces of the earth, right? So there was this one video I watched, for example, now in Binondo by Dr. What's his name? So he's a very famous geotechnical engineer here in the Philippines. And there was this building in Binondo where an adjacent lot, they were what do you call this? Naghuhukay sila, very deep. And what happened to the building that was present in there? The wall actually what do you call this in English? From being straight, the wall kind of deflected. And because of that, one of their projects was to correct that. Because on the adjacent lot, soil was being digged, the existing building was affected. So they had to put some interventions, mechanical interventions, wherein they had to inject some kind of technology wherein they would raise the foundation by a few meters, and that will hopefully make it straight again. So it's erosion. That's what the problem of erosion. And by employing nanotechnology, we can reduce erosion, according to Kumar, Sharma, and Singh in their publication called Role of Nanomaterials in Improving the Durability and Erosion Resistance of Soil. So one of the other advantages is reduction in soil plasticity and shrinkage. Nanomaterials like nanolime and nanocement can reduce soil plasticity and shrinkage, improving its properties. These materials help stabilize expensive soils, which are prone to significant volume changes with moisture variation. So sometimes they use expensive soils, especially that use yung mga limestone because apparently they're good. They're good material. But one of the drawbacks to that is, yun nga, it's prone to volume changes with moisture variation. So because we have nanomaterials, which are very small, we can reduce its vulnerability to shrinkage because we can improve its properties. So that's one of the advantages. And still related to erosion is increased resistance to water infiltration. This was seen by Monsor and Morsi. So hydrophobic nanomaterials. Hydrophobic means that it is, when you say something's hydrophilic, it's water loving. When you say something is hydrophobic, it fears water. So these materials kind of repel water. Not just kind of, but they do repel water. And they modify the surface properties of soil. Its water resistance is useful in areas with high water table levels or frequent rainfall, preventing erosion and reducing water damage. So yeah, I mean, you can like build a lot of infrastructure that's next to, let's say, for example, an ocean, or for example, you're in a mountain and then next to it, you're in a beautiful, let's say, ocean, right? So this is a concern in those cases, and I'm sure maybe in my limited knowledge, there's probably other cases where this can be a concern. So these are the types of nanoparticles in soil stabilization: nano, silica, CNTS, and nano-lime. Nanoparticles are increasingly used in soil stabilization due to their unique chemical properties which enhance the soil's physical and chemical stability. With nano, silica, CNTS, and nano-lime allowing enhanced durability, moisture resistance, and structural integrity. Nanoparticles for water retention and soil erosion. Nanotechnology plays a vital role in enhancing soil's water retention capacity and reducing erosion. By incorporating nanoparticles like nanoclays and nanosilica, soils can retain moisture more effectively, especially in arid environments. So yan, sa mga humid places, right? These particles work by increasing the soil surface area and bonding capabilities, which slow down water loss and help soil withstand harsh conditions. In terms of erosion control, nanoparticles improve soil cohesion, creating a more robust matrix that resists breakdown from wind and water. This stability is crucial for infrastructure near bodies of water or areas prone to heavy rainfall, helping to prevent landslides and sediment runoff. So we also have nano cement and nano lime additives. So based on my limited knowledge as well, apparently limestone is very favorable as a material to be added to soil. So nano cement and nano lime additives enhance construction materials by improving strength, durability, and resistance to degradation. So I don't know guys, but if you know about Monterasas in Cebu, and this is a project by Slater Young, it's in a mountain, and then there's a bunch of nice houses, residential area. This is project, right? And he consulted a geotechnical engineer, and nung naghukay sila, they took the samples of the soil and they found out that it was predominantly limestone. And because of that, they found it ideal, safe for people, that they would build those infrastructure that, you know, those architects were able to imagine. And because of the collaboration between architect, structural engineer, and the geotechnical engineer, they were able to not only conceptualize these imaginations, but make it come to life. So if you want to see one example of where lime was added, where limestone, was playing a good role in soil stabilization, one of it is the one I mentioned in Monterasa, Cebu. Nano cement accelerates hydration, creating denser structures, while nano lime speeds up carbonation for stronger binding. So both reduce porosity and enhance the longevity of concrete and soil stabilization, offering sustainable, high-performance solutions for infrastructure. So, too much and too little of anything is bad. So you need to have some moisture, right? So nano cement accelerates hydration, and soil, on the other hand, needs to also maintain that right level of hydration. So we have improved soil compaction. So it's important for soil to be compacted. And nano-sized clay additives and nanopolymeric stabilizers represent advanced solutions for enhancing soil compaction and stability. The high surface area and unique structural properties of nanoclays improve particle interlock, cohesion, and load-bearing capacity, while reducing void spaces and permeability. So again, if you look at the permeability, we don't want also water to come in, but we also don't want water to come out. So we have to maintain a certain ideal level of moisture in the soil. Nanopolymeric stabilizers form a robust network within the soil matrix, significantly increasing tensile strength, elasticity, and long-term durability. These materials effectively mitigate issues such as swelling and shrinkage, offering superior performance under varying environmental conditions. Collectively, they provide sustainable, cost-efficient alternatives to traditional stabilization methods, advancing the field of geotechnical engineering. So this is nano titanium oxide for soil stabilization. So nano TiO2 is increasingly used in soil stabilization due to its photocatalytic properties. So when exposed to sunlight, nano TiO2 can trigger chemical reactions that break down organic contaminants. So as we said earlier, there's a biological component to soil, and there are always these organic or those small microorganisms that can contaminate the soil. And what it's saying here is that catalytic speeds up reactions, and because when there is exposure to sunlight, it will speed up chemical reactions that will break down those contaminants. So this helps to purify soils in polluted areas, and this makes it particularly useful in urban settings and industrial zones where soil contamination is a concern. Additionally, nano titanium oxide enhances soil strength and stability. Its small particle size allows it to fill gaps between soil particles, increasing density and reducing permeability. This leads to improved compaction and load-bearing capacity, which is ideal for construction foundations, roadways, and embankments. So when it comes to technical feasibility, it is therefore very feasible. Nanotechnology in terms of soil stabilization is technically feasible and has been demonstrated in laboratory settings and small-scale field trials. The use of various nanoparticles such as nanosilica, nanoclays, and carbon nanotubes has shown improvement in strength, durability, and resistance to water. I would also like to add that it is very technically feasible, but it hasn't been upscaled yet. So there are challenges in that area. However, it is on an industrial level very much worth it to invest in upscaling nanotechnology and soil stabilization, mainly because there's a big demand for it and it's already been shown to be effective. Another kind of challenge is also the acceptance of the public. Engineers all over the world might want to stick to traditional methods just because it's relatively new and they might not understand so much about nanotechnology. But certainly these hurdles can be short-lived, it can be overcome, and during time, such limitations will be overcome by its technical feasibility and what I see na that the benefits are outweighing so far the other challenges and potential hindrances to it. So, yeah. So, in conclusion, nanotechnology is crucial in making our environment and infrastructure more durable and resilient. With innovations like nanoclays and polymer-based nanomaterials, soil stability is enhanced, helping it resist moisture and environmental wear. This means less erosion and stronger foundations, especially in challenging climates. In areas with high rainfall, hydrophobic nanomaterials help prevent erosion by making soil surfaces smooth, more water resistant. In short, nanotechnology offers practical solutions that make everyday structures safer and longer lasting, even in the face of natural challenges. Thank you. And I would also like to add that my grandfather, he always says, because he's an engineer, a doctor saves one life at a time, whereas an engineer saves thousands of lives at a time. So, thank you.